Here's a language model with the temperature slider at 0. Ask it anything and you get this. Safe, sensible, a little boring. The best way to learn is to practice consistently. Now slide temperature up to 1.5. Same prompt. The best way to learn is to befriend a sentient cheese wheel. Wild. Same model, same prompt, the same frozen weights. You only moved one slider. The model didn't get smarter, and it didn't get crazier. One math function is doing all of this, Softmax, and its temperature knob. That's today. Every time a model generates a word, its very last step produces a raw score for every possible next word. Tens of thousands of them. Softmax is the function that turns those raw scores into clean probabilities that add up to 1. And temperature is a single knob that warps those probabilities, making the model bold or cautious right before it picks. Let's see it. Concretely, imagine 5 candidate next words, and the network hands you a raw score for each 2.1, 0.8, minus 1.3, 4.2, 1.1. They can be negative or large. They're not probabilities. Run Softmax, and they become a clean probability distribution. Token 4 scored highest, so it gets the biggest slice. Now they all sum to 1, a real distribution, and token 4 is the favorite at 68%. And temperature can push that 68% up toward near certainty or down to barely a lead. That's the whole video in one picture. In the next 15 minutes, here's the plan. First, what Softmax actually does. Turning raw scores into a probability distribution with real numbers, not hand-waving. Second, the temperature knob, why one number flips the model from cautious to chaotic. Third, a trace-along. We'll watch a single next word actually get chosen, and stick around because there's a bonus. The other sampling slider almost nobody explains, top P. I'll unlock it right after the cheat sheet. By the end, you'll know exactly what both temperature and top P in any API really do. Where do those raw scores come from? Straight out of video 2, the unembedding matrix, the last matrix multiplication. Its output is a vector of raw scores, 1 per token. They have a name, logits. A logit can be anything minus 1.3, 0, 4.2, 12.7. Unbounded, positive, or negative. But a probability has to sit between 0 and 1, and a whole set of them has to sum to exactly 1. Logits do neither. So we need a converter, take raw logits and turn them into a valid distribution we can actually sample a word from. That converter is Softmax. Once we have probabilities, picking a word is just rolling a weighted die. Softmax is just 3 moves. Move 1, exponentiate each score, raise e to the power of it. That makes every value positive and exaggerates the larger scores. Move 2. Add up all those exponentials into one grand total. Move 3. Divide each exponential by that total. After step 1, everything's positive. After step 3, everything sums to 1. A valid distribution, guaranteed, for any input. Let's do it with real numbers. The cat sat on the 3 candidates with logits 2, 1, and 0. Watch every step. Step 1, exponentiate. E to the 2 is about 7.39. That's mat. E to the 1 is about 2.72. Rug. E to the 0 is exactly 1. Roof. Step 2, sum them. 7.39 plus 2.72 plus 1 is 11.11. Step 3, divide each by 11.11. Mat becomes 0.65. Rug, 0.245, roof, 0.09. They add back to exactly 1. And notice what exponentiating did. A logic gap of just 1 between mat and rug became 67 versus 25%. Softmax amplifies the leader. Here's the formula, and you've earned it, because you just did every step by hand. Softmax of the xi equals e to the xi, divided by the sum over all j of e to the xj. Map it to what you did. The top is this 1 token score exponentiated, step 1. The bottom is all of them added up, step 2. The division bar is step 3. That's the whole thing. Forget the symbols. Just remember 2 words, exponentiate, then normalize. Why the name Softmax? 2 halves, The max part, it spotlights the largest score. The winner takes the biggest share. But the soft part, it is not all or nothing. Every token keeps some probability, even the losers. Compare hard max 0, 0, 1 to Softmax's smooth version 0.09, 0.24, 0.67. That softness matters twice over. It's differentiable, which is what lets the model learn these scores in the first place. And the output is always a valid distribution, positive and summing to 1, no matter how huge or negative the logits were. Temperature is almost embarrassingly simple. It changes exactly one thing. Before Softmax runs, you divide every logit by the temperature, T. At T equals 1, you divide by 1, nothing changes. That's the default Softmax we just did. At T below 1, you divide by a small number, pushing the scores further apart. Softmax then makes the distribution sharper. At T above 1, you divide by a big number, squishing the scores together, and the distribution comes out flatter. Let's prove both with numbers. Low temperature first. Same logits 2, 1, 0, but now at T equals 0.5, divide each by 0.5 and the logits become 4, 2, 0 pushed further apart. Exponentiate. E to the 4 is about 54.6, e to the 2 about 7.4, e to the 0 is 1. Sum is about 63. Divide through and the distribution has gone spiky. Mott jumped from 67% all the way to 87. Low temperature makes the model focused, confident, and repetitive. At T near 0, it's called greedy decoding. Now high temperature. Same logits 2, 1, 0 at T equals 2. Divide by 2 and the logits become 1, 0.5, 0 squished close together. Exponentiate, about 2.7, 1.65, and 1. Sum is about 5.4. Divide through, and the distribution is flattened out. Mat dropped from 67 to 51%, while rug and roof now have real chances. High temperature makes the model diverse, surprising, and riskier. Push the knob to its limits, and let's actually see the numbers, not just words. As T approaches 0, the same logits sharpen to about 99% on mat, effectively argmax, greedy decoding. Ask twice, get the identical answer. At T equals 1, the default we computed, 67, 24, 9. As T grows huge, they flatten toward 36, 34, 34, nearly uniform, a coin flip among all words. That's noise, gibberish. From near certain T to an even coin flip, same logits the whole time. Real use lives in the middle, around 0.7 to 1. Let's line all three up. Same logits 2, 1, 0 the whole time. At T equals 0.5, sharp. Mat at 87%, safe and focused. At T equals 1, the default. Mat at 67. At T equals 2, flat. Mat down to 51, the others climbing creative and loose. One knob, 3 completely different personalities, and the model's weights never moved a millimeter. Only the sampling changed. Quick one for the comments while we're here. What temperature do you actually use when you chat with an LLM? I'm genuinely curious whether most people just leave it at the default. Drop your number in the comments. I read them. Time to bust the single most common misconception about temperature. The myth higher temperature makes the model smarter or more creative. The reality, same weights, same scores. All you did was widen the sampling net. The model didn't think any harder. You simply gave weaker candidates a better shot at getting picked. Creativity here is just controlled randomness, not extra intelligence. Let's trace one real next word, end to end. The prompt, the cat sat on the... Step 1. The network produces logits mat 4.2, rug 2.1, roof 0.8, sky minus 1.3. Step 2, and this is the part we won't skip, apply temperature. At T equals 0.8, divide every logit by 0.8. Mat becomes 5.25, rug 2.63, roof 1, sky minus 1.63, roof 1, sky minus 1.63. Below 1, so the scores spread apart. Step 3, Softmax those scaled logits, mat 82%, rug 12, roof 4, sky 1. Sharper than the default, exactly as we'd expect from T below 1. Step 4. Sample, roll a weighted die. Mat usually wins, but not always. That small chance on rug is real, and that's the point. Step 5. Append the chosen word and feed the whole sentence back in to pick the next one. Notice the order: divide by T, then softmax, then sample, the same pipeline you worked by hand 2 slides ago. And softmax runs once per token, every token. Every single word you've ever read from an LLM survived exactly this lottery. Watch it move on a real prompt, write the start of a story. At temperature 0, greedy. The safest opening, the sun rose over the quiet town. At 0.7, the sweet spot, the sun quad over a town that hadn't slept in years. Vivid, still coherent. At 1.5, the sun, a drunk lighthouse, hiccup neon across the cheese wheel town. Chaotic. And there's the cheese wheel from our hook. And every one of those words came from a softmax distribution. Even that very first the was a pick from something like the 58%, A21, it 9, dawn 4. Temperature decided how boldly it chose. Same model, same prompt, same weights. Temperature alone walked it from boring to unhinged. Here's the whole video on one screen. Pause and screenshot this. The pipeline, logits, exponentiate, divide by the sum, probabilities, then sample. Softmax is exponentiate, then normalize always positive, always summing to 1. Temperature, below 1 is sharper, 1 is default, above 1 is flatter. At the limits, 0 is greedy and infinity is noise. Top P, which we're about to unlock, keeps the smallest set of tokens whose probabilities sum to P, then samples from just those. And the big idea to tattoo on your brain, a model's creativity is sampling choices, not smarter weights. Bonus segment, unlocked. If you only needed the core idea, you've already got it. But there's a second slider sitting right next to temperature in every API, and almost nobody explains it. Top P, also called nucleus sampling.